All right, so if I want to do this one problem, so we'll just do this one problem from this thing, and then you both, all of you will do this one. You'll finish up this example and this other example as well. So, all right. So let's talk about this. So we have a sample space. S is all the ordered pairs of two whole numbers. The first one from 1 to 3, and the second from 1 to 4. So the first one, has to be 1 to 3, so I have choices. So we are talking about ordered pairs, so all I can choose in this group is 1, 2, and 3 for the first order pair, for the X, if you want to call it an X, from our order pair days. And then the second one I can choose from 1, 2, 3, or 4. So if I want to write out the sample space, I'm going to do it in a way to try and help me make sure I get them all. So I'm going to fix the first one as a 1, and then I'm going to come up with all the possibilities of 1 comma whatever I could get. So there's one possibility. What's another possibility? 1 comma 2, 1 comma 3, 1 comma 4. Is there anything else? 1 comma 5? No, the second one only goes from 1 to 4. The first one goes from 1 to 3. So there's 4 things in my set. And those are all the 4 things, starting with the first number being 1.
So if you would put 1, 2, 3, 4,
No. You can list this list in any way you want. The order doesn't matter. I'm just trying to go over a way that we can make sure that we get them all. And you could get them all in that way and say 1, 2, 3, and list all the ones on the second one kind of thing. So just make sure, that you're hitting them all by being consistent with the way you write it down. So that's sometimes the hard part. So I'm trying to go over that consistency. So I did all the ones. You see how I got all the ones in the first one? Okay. So if I wanted to go now, what would be my next number I can go to? 2. So 2, and let's start off at 2, 1 in particular. I like that, Colin. So 2, 1. We start off at 2, 1. Let's get all the 2s. Starting off with 2, 2, 2, 2, 2, 3, 2, 4. Those would be all the ones that have a 2 in the first value. So this is one thing, even though it's 2 numbers. This is one possible outcome. This is one possible outcome. Here's another possible. I have 8 outcomes right now, but I also have another number that can go in the first set. 3, 3, 1, 3, 2, 3, 3. Oh no.
You can do it.
3, 4. I gave up and went down to the bottom one.
It's there.
I kind of need brackets. I'm not going to test you on the brackets or anything, but that's the set. That's the set S. Yeah. That's our sample space. I have how many things in this sample space? 12 things. So that is alright. That's what most of our probabilities will be out of when we're talking about calculating these probabilities that we want. Okay. So now let's set up A and let's set up B. So, and I don't know if I have enough space on this piece of paper. I really,
kind of go up top a
really
little
doubt it.
bit.
So,
Like this. Or like this. Kind of go up top. You know what I mean? You can fit
okay.
it all in there.
Maybe I can fit it all in there
Yeah,
up here.
I mean, if you go up top, yeah.
So if I talk about A, let A equal the sum is even. So the sum of the 2 numbers is even. So, so this one, outcome is not possible because 2 plus 1 is 3. It's not even. Is this one possible?
Yes.
Yeah. This one?
No.
You get it? So we're looking at the, just adding those 2 numbers together. If that's even, it's in this group. So somebody give me the first one. Let's try and stay in order. 1, 1. What else?
1, 3,
1, 3. 2, 2. 2, 4. Thanks.
3, 1.
Whoa, whoa, whoa. Slow down there, Sparky. 3, 1. What did he say? Is that what's next? 3, 1. 3, 3. Is that it?
Yep.
That's it. How many things do I have in A?
6.
Got 6 things in A. I had 12 things in my sample space. Now let's do B. So I'll write B over here. Hopefully I can fit it.
Basically everything
After 2, 1. So B says the first number is prime. First number is prime. So is this prime?
No.
So no, 1 is not prime. So okay, so 2 is prime, 3 is prime. Right, if you're not sure what the definition is there, look it up. Right, this means you can't multiply 2 whole numbers together to get that number. So is what prime means, and 1 is just a standard. No, it's not prime. So none of these are it, right? But 2 and 3 are it, and we were just looking at the first number, so all the rest of those. So we'll have how many total in that group?
8.
Still got a little close there. 3, 3, 3, 4. All right. Oops.
Oh, you're really nice.
Is it better? Oh,
Yeah.
Thanks.
Yep.
I think my writing's better with these pens.
See?
They're so much better.
Is it?
Oh my God.
Yeah, Bree.
Yeah.
Look.
Probably be a retarded question, but I'm
No,
still
don't say that
lost.
word. Don't say the word in general.
Oh, yeah,
Yeah,
that's
that's
bad.
bad.
Bad, not PC, sorry.
Yeah.
This is gonna be, I'm just still lost in the wording.
Uh huh.
This one is especially confusing.
It is.
wasn't
It
as
is
straightforward as the
especially
previous
confusing. Is
example.
there
I am just
any particular part that?
When you're
About what I'm getting
saying
at?
the number is 1 to 3, and then you're saying another, in my mind, I'm like, where's the other set? 1 to 4.
You have to make them.
That's what I'm thinking too.
Yeah, but you have to kind of create those 2 sets and then put the
Yeah,
word
like-
together.
Where are the two?
I'm sorry, I'm being late. So anyway, I'm really confused in terms of the
How do you do it?
event,
Two?
event A, the sum of event, like,
All right,
Even number.
so same idea between the 3 of you. So let's make sure we hit it. So we get the idea of ordered pairs, right? So we've talked about ordered pairs in general last semester with X and Y's, right? So we're thinking of X and Y's here, and those ordered pairs. So the
Right.
parentheses are used to establish that it's an ordered pair. That's all those parentheses are, right? So this is one ordered pair, 2, 3, 4, and so forth. So how do we come up with that? Well, the first number, so we're describing it, is, right, any number between
1 to 3.
1 to 3, where does it say? All
there.
ordered pairs,
1 to 3.
the first
see?
one from 1 to 3. So my first number, right, is
Mhm.
any 1, 2, or 3. My second number can be anything from 1 to
4.
4. So I'm coming up with this list, right? So I might make you do this on a test where I see if you can understand the sample space that I'm describing to you. Hope is that we can. So, yeah.
I think it's the wording, it's still.
It is the wording, yeah.
It's the word.
It's
just-
still confusing me because when I read that, I'm like, okay, there's one set of numbers, there's another set of numbers from 1 to 3, there's another set of numbers
From 1 to 4. And then
Yeah.
make ordered pairs from them.
Yes.
So every number has, that the first
Yes.
set has to be 1 to 3. So you just go 1, 2, 3.
The
1, 2,
ordered
3,
pair
okay.
makes the set.
And then the
It's
second.
not the 1 through 3 and the 1 through 4.
I'll show you my
It's
notes.
the
I
ordered
have it all
pair that
colored.
makes the
That's
set
what I do
that
too.
we're
I
talking
color
about.
It's color, it's easier to see
So
with
maybe
color.
1 to 3 is green. It's all the numbers I underlined in green.
Right.
From 1 to 4 is with the red. It's all the ones, well, even these ones. It's that, the second number here.
The second one is easy because then you look at it, you're like, okay, the first number has to be prime, so you're like, that cuts out.
So
all the
setting up
ones.
these
So you
sets
do all
and
the
these
2 and
events
3,
is a
so
little
2
bit
and 3 is
challenging, is
prime.
what I'm hearing, okay?
Yeah.
You just have to read.
So
it.
let's
Like,
try and
it
get
is
it down and
confusing.
we'll
It took me a little
try
while
and
to
work on the
understand.
next one is also, I think, a little challenging to think about the sets, maybe not.
No, I like that
So
one was hard.
let's just go through the probability and then hopefully with other examples on your homework and stuff, we can get this down because I'm not sure how to explain it more
Okay.
than I have, okay? So let's try and get down the probabilities. We'll talk about other possible sample spaces as well.
Okay.
So So we talked about how many in we have in A. We have 6.
Yeah.
I have
8.
8 in B, and I have 12 in my sample space. So now we can calculate the probabilities of A for.
Right.
So
6.
I have how many total?
6.
6 out of. I can't write on there.
12. You could erase it.
Can't write on the screen. I did that one semester in
Oopsie.
another college. I won't tell you which college.
Uh-oh.
So we said 6 out of
12.
12.
Or 1/2.
So, and we could write 1/2. Remember, I kind of like this version.
Right, I do.
So just to deal, all right, kind of thing. So this is how you want to do it on the test because it just sets up our work a little bit easier after that. So B, 8 out of 12. We do have to be able to simplify those just to make sure that our homework is correct. So on your homework, you would write that more as 2 out of 3. Yeah, 2/3. And the other one on your homework, you probably want to write as 1/2. I think your homework actually gives you some decimals too, right? So you might have to convert it to decimals. We were talking about that with Charlie last time, I think. Questions so far? Besides the whole setting up the sets. All right, so.
Lots of questions, but anyways.
And lots of questions. So now we want to talk about these groups, these sets, right? So there's a difference between the set notation, right?
Right.
What it's asking me here is looking for the set. A equals, A and B equals, and then here's the probability of these things.
Right.
Right? P of A and B. So now at those stages, those are 2 different questions.
Right.
So, okay, so if I'm looking for A and B, I'm looking for all the things in A and B. And B. There's got to be in both.
Oh, yeah.
Both. Not one or the other, but both. A and B, strictly. Right? You're not wearing red and green unless you have red and green on today, right? You could be wearing red or green, right? In a sense. So I'm trying to make sure we get those words down. All right, so P of A and B, what's in both of these? That's 2, 2, he says, is the first one? 2, 4, 3, 1. Let me underline these things as we go. Since I got different colors, look at this. 2, 2. There's 2, 2 in common. We said what? 2, 4. 3, 1. And 3, 3. Because these prime numbers that started off in first have to be over here. All right, 1 was not a prime number in the first set, so it's not going to be over there. So we have those 4 things. Can I fit them all here? No, I cannot.
You can scoot up above.
I can do it. Thank you for your confidence in me, Colin. I appreciate it.
Even if they don't work, you can erase them.
Yes, exactly. You don't have to commit, no.
I feel like I do. I don't know.
Don't have to commit.
All right.
You don't like it.
Questions about that set? I should have used green down there, huh?
No.
All right. Well, I'll figure this out.
It's okay.
So the second set, the OR set. OR is going to be a lot bigger. It's going to include everything from both. Right? So it's going to include everything from this A set and everything from this B set. So an easier thing is almost to point out what it's missing, I think. It's missing anything. So this has got all the ones starting with 2 in it. This one's got all the ones starting with 3 in it as well. This set only has 2 of the ones starting with 1.
Yeah.
So it's missing a couple of these ones. So this one's going to have everything except for those couple of ones that we're missing.
That's exactly right.
Thank you.
So it's just 1, 1.
So 1, 1, 1, 3, and then everything else.
Yeah, from 2 on.
2, 1. Yeah, I guess I'm going to write it all down. 2, 2, 2, 3, 2, 4.
See how you torture us. You get to experience
I
it.
know, right? I have to do all this writing. It's horrible.
And I complained the whole entire time.
So much playing. So much. So bad.
No question.
3, 2, 3, 3.
I was like, how dare you?
Sometimes it just helps writing these things down.
No, it really was though.
So we were we're just missing 2 things out of this set, so I should have 10 things here
See,
listed in this
you
row,
do.
right? Where I have 4 things in this and group.
Can you explain the difference just really quick again?
So,
What's
and
and or and?
Between those words,
Verbal.
right? So we were using colored words last time, where we can go somewhere else.
Oh, would this be on that Venn diagram?
You can use the Venn diagram for it,
I
yeah.
think the Venn
So
diagram
what
makes
would
it
the
really
difference
easy.
be between purple, the one you did in A and B, or A or B?
So the A and B would be in the 2
sides.
circles. The
Okay,
things
got
that
it, got it, got it.
in both circles.
And then-
Whereas you get everything outside the circles as well.
Okay,
So the or statement.
would be everything outside
Yeah.
the circles.
So if these are my 2 groups, right? And I say A or B, then it's everything.
Right.
In that A
Both of
or
them.
B.
got it.
So you take all the numbers in these 2 circles. If it's A and B, then you're really only talking about this space.
Got it.
So
Okay.
this is your and space, which is a lot smaller than the or space. So all of this is or. Here, here, and here.
Okay.
All 3 of those spots.
So then what's the, oh no,
No, you don't count the ones in the middle twice.
That's the biggest problem with the or, is duplicating those, right? If I'm counting up the or, it's really easy to forget, and that's what helps with the Venn diagram, as you can see, I'm not gonna double count it. But when I don't give you the Venn diagram anymore, the Venn diagram. So, if I don't give you the Venn diagram anymore, then it's a little lost that we're double counting.
Right.
But always with or statements and calculating the probability or statements, I can double count that group easily, because they're both in A and B, right?
got it.
This set of A and B, right, is both in this group and this group. So when I'm thinking of the or statement, I could double count them very easily. So by using this. All right. So probabilities now. So how many things do I have in the and group? 4 out of total 12.
Yeah.
All right. So and statements still have the same denominator. For B, it's 10. I got 10 things out of 12 total. So now we want this B prime, this B apostrophe. What does that mean? Complement space, the opposite of B in particular, which had 8 things in it.
Yeah.
So we'll have 4 things. That's beautiful. We're seeing that rule
Yeah.
of complements as well that we use a lot. So this complement space should be everything. Let me use orange. Should be everything that's not included in B, which is just the ones that start with 1.
Exactly.
All of those 4
Yeah.
are not listed in B. So we're going to list them in B prime. So 1, 1, 1, 2, 1, 3, 1, 4. All of these ordered pairs is what's in B prime. The complement space, however we want to say it. So I have 4 things total in there out of how many?
12.
So 4 out of 12 is my probability of not B.
So you prefer it to not, for it to not, narrow it down? I don't know. Simplify. You prefer it to
Not
not simplify it?
I prefer not to simplify it because typically we do stuff with it.
So if
So-
you do simplify it, you're gonna mark it on.
Just do it. The homework does seem to focus more on the the decimals. So actually, doing 4 divided by 12, which would be like 0.3333 kind of thing. So you'd have to round somewhere. So that's I don't like that. I don't like rounding. So I'm a math person. This is technically our math chapter. So I really don't like rounding in this chapter because of that reason. We don't know what we're doing with this thing. All right. And neither do actually, if you go to Vegas, they don't like rounding either there. Right, unless it's rounded in their favor. If it's rounded in their favor, they might like it. But they want to calculate those probabilities exactly, and then they really just earn cents off of the bets in most cases. So right, you're not talking about much money earned off of each bet. So using probability to figure out how much over they need to go. So right, they'll give you the odds, right, kind of thing, and they bump those odds up with just a little bit. So instead of 4 out of 12, they might use they might give you 3 out of 12, or actually 5 out of 12, and then that way you have, or no, 3 out of 12, so that way you have less of a chance of winning, kind of thing, instead of 4 out of 12. So they might do stuff like that.
So that little sign means right by the B, that means,
A prime. So we call it B prime, the complement set.
or opposite?
The opposite is how we really think about that. I like the way Jasmine said that. The opposite space, right? Of whatever we got. Right. Whatever's not in B that is in our sample space is how we say it. So, all right. So if I add, right, I don't even have this A prime. I have A. I know it's 6 out of 12. And if I add A prime to it,
Same.
so yeah, I don't like this example. It's a bad example.
It's like a trigger. It's like a
So it should be different things, but those two things equal one, right? Complement space we talked about, right? If it was at a 30% chance of rain outside today, no, it doesn't. Then that means what percent chance of not rain? That's the idea of the complement probability, right? We can use this all day long, and we will use this quite a bit. The idea of the complement space, and this formula in particular that we talked about last time